Okay, so we're gonna start the next lesson. It's 3.8. Implicit differentiation. Implicit differentiation. Now let's see how we're gonna derivate function like this: x squared plus y squared equals 1. Now all the functions we derivate, we found the derivative before was something like this: y equals f of x. Y is a explicitly function of x. But here, of course, we can find y in terms of x. But we can find the derivative without doing that as well. So let's see how we're going to do that. Now, if we want to do that, what would we do is we just find the d over dx of x squared plus y squared and d over dx of 1. Whatever you do for the right hand side, you have to do with the left hand side, right? It's an equation. Now what we have here is that d over dx x squared plus d over dx y squared. What about on the right hand side? It's C. Good. Now you can derivate the first term in terms of x because it's a function of x, so explicitly function of x, so you can put 2x, right? Plus this is not a function of x, 1. So what would you do? What did we learn from the previous chapters? When we have some situation like that, what do you do? What rule can we use here? Now, what is our aim? Our aim is to find what? Dy over dx, right? This is what we are trying to find. So what do we do for the second term? Can anybody guess? Yes, yes. Dx over dy. Huh? It's just yeah. So no, my question was what rules do you follow? Because you want to find your derivative y in terms of x, right? Chain rule, yeah. So how do we apply chain rule? If it were you put dy over y squared, then dy over dx for 0. Just like you treated u. The chain rule, right? Is that correct? Then y is of course a function of x. That's why we could do it. 2x plus, what is this one? 2y times dy over dx equals 0. Now what is dy over dx? Negative 2x over 2y. So dy over dx equal negative y over x. that make sense? Any questions? Is there anything complicated that you don't understand? Please ask. Good? Are we all good? We all good? Okay, if you do understand that, let's do this example. Just all the examples, right? Find dy over dx. The function is, the equation is y to the power 4 plus xy equals x cubed minus x plus 2. Okay, let's find dy over dx. What do you do first? Find d over dx, both sides. Differential operator. Derivate both sides by x in terms of x. second term on the left hand side is a product x and y. Right? So you have to take it as the product rule. X, then y, y. Now what? So you got you were here combined, right? So what do you need to do then? What did I do previously? Chain rule. So if you use chain rule, what do you get? You put d over d by y times d by what is right? And d over d by y is equal to what? 1 times d by d. That makes sense? Yes. That's how the chain rule works. That makes sense? You always. Okay, let's do this. Okay, I see that some of you have problems. Let's do this. So what you do first, you take the derivative of both sides in terms of x. That's why I always ask you to write the differential operator and use the basic rules. What is the basic rule that I can use here? You have summation. So I'm going to use some rules first, one at a time. Okay, piece by piece. D over dx y to the power 4 plus d over dx x times y equals d over dx x cubed minus d over dx x plus d over dx 2. Is that step make sense to everybody? Okay. Don't think that you spend more time on this, just write like that. Now, you have to derivate y in terms of x. Can you do that at once? Now, what do we need to do? What rule can we apply to derivate that? Product rule? No, you have only one function, right? Y to the power 4. So what do you do then? Chain rule. Yeah, you do d over dy because I know that I can derivate y in terms of what, not in terms of x. Right? And then this is y to the power 4. And then you need to have dy over dx. Does that make sense? That's how we apply chain rule. And now you have a product. I take x out and derivate y in terms of x. See that x times d over dx y, because we had only d over dx, we didn't have d over dy, plus y times d over dx x. And for the first term in the right hand side, it is 3 times x to the power 2 minus what? 1 plus what is that? 0. Good. So the first term in the left hand side, right? You have 4 times y cubed. Now you can derivate. See that? And then you have dy over dx. You're going to keep like that because we're going to do anything for that. Okay. Now you may thinking, oh, why don't I apply chain rule? Yeah, you can apply chain rule, but what do you ended up with? What do you ended up with? If you apply chain rule here, what do you get? You get dy over dy, again dy over dx. Now this is equal to 1, again dy over dx. So that's it. We cannot proceed anymore from here. Does that make sense? Right? Are we good? Right? So now I can keep it like that. Then what about this one? This next term. Plus x times, this is dy over dx. Because we cannot do anything for that. Just leave it like that. Okay? Because that's what we need to find. Right? We can solve for it later. Plus y times, what is this one? D over dx. D over dx x is equal to just 1. So just 1. This is 3x squared plus, sorry, minus 1. Good. So now we have what we need to find, dy over dx. So I can move this y into the other side, 3x squared minus 1, y minus 1. And then from this side, you can take dy over dx as a constant, and sorry, a factor, common factor, and then this is y, 4y cubed plus x. So your dy over dx is equal to 3x squared minus y minus 1 divided by 4y cubed plus x. That's our answer. Does that make sense? So always use your basic rules. Always use your basic rules, right? Always. Okay. You can work out a couple of problems from that section. 3.8. Problem 6. So this is the problem. Find the derivative. Find dy over dx. Of differentiate the expression with respect to x, assuming that y is implicit a function of x. So you need to find d over dx, x plus y. This is what you need to find. You don't have to, I think, find dy over dx, but if you ask to find that, what would you do? Yeah, so you can use the square, right? You can put this as u, right? Right? So you get d over dx u to the power half, or you can write d over du to the power half, and then du over dx. Taking that as u. So this is half times u to the power negative half, and du over dx. Here half times u to the power half is negative half is 1 over square root of x plus y, and then d over dx x plus y. Here it's half x plus y. This is d over dx x plus d over dyx. So you get 2 times square root of x plus y. And then here it's 1 plus dy over dx. You need, that's, I think that's what all you can do in that problem. It's problem 6, right? 3.86. So you can name this as y prime if you want to. Sometimes they write as 1 plus y prime. See the other problems. Does that make sense? 8. Okay, let's take this one. Find dy over dx of this expression, y over x plus x over y equal 2y. This is problem number 17. Take it down to simple things. The first two terms in the left hand side are the product rules. Right? So the product. Take it as a product. Sorry, product. You can take it as a product, or you can take it as a quotient. I'm sorry, it's a quotient. So this is d over dx y over x, right? I can write the some rule over this side, d over dx x over y equals d over dx 2y. We derivate in terms of x, not in terms of y. Okay. And then for the first one, you have denominator is x. So you have x squared. The first term to derivate is y. So you have x times dy over dx. And then minus, you're going to derivate the second, the denominator. You put the numerator here, y, d over dx, x. Okay. Does that make sense? And then, sorry, I had to write this letter properly. D over dx, x. And then plus y squared. Take first derivative is the numerator. So y d over dx, x minus x d over dx, y equals 2 times d over dx, y. Now, we cannot do anything further to d over dy over dx. Okay. And d over dx, x is equal to 1. So this is x. You can say this is y prime or dy over dx minus y times 1 divided by x squared plus y squared. This is y times 1 minus x times dy over dx equal 2 times dy over dx. I should be able to solve for that. Solve for dy over dx. I can take all the dy over dx terms to one side. So you have x dy over dx over x squared, right? Minus y over x squared plus y over y squared minus x times dy over dx over y squared equals 2 times dy over dx. Right? So if I take all the dy over dx terms, so this is 1 over x dy over dx minus x over y squared dy over dx minus 2 times dy over dx equals y over x squared minus y over y squared, or you can put 1 over y, 1 over y. That's it. Right? And I can take dy over dx as a common factor. So you get 1 over x minus x over y squared minus 2, right? Equals, you want to take x squared y as a common denominator, then you get y squared minus x squared. Right? And you can further simplify this by taking this side. Y squared x is the common denominator, so you get y squared here. You get here x squared minus 2xy squared equals y squared minus x squared divided by x squared y. That makes sense? Now you get, now one of the y's cancel to one of the y's here. One of the x's cancel to one of the x's here. So you get y times y squared minus x squared divided by x times y squared minus x squared minus 2xy squared is equal to dy over dx. That's our answer. Does that make sense? Is there anything that could make sense to you? But it's difficult to understand. Any questions? Which step, Bryson? 1, 2, 3, 4, 5 here. There. Line below. Okay, what I did was I got all the dy over dx terms to this side, to left hand side. So the first term here is x divided by x squared times dy over dx, right? So when you get x divided by x squared, you get 1 over x times dy over dx. Did that term make sense? Okay. Then the second term that has dy over dx is also into this side. You have x over y squared dy over dx. That term is here. Okay. Then the third term is in this side. So I took it to the other side. So it comes with a negative sign and negative dy over dx. Makes sense? So good. So this term doesn't have any dy over dx term. So I took it to the other side. The sign changes. Y divided by x squared. Right? And then this term was in this side. So it's y divided by y squared. That means 1 over y. Do you understand what I did from here to here? Okay. So I distributed the denominator over the different terms on the numerator. That's what I did. Does that make sense? That's algebra. So only part of derivatives applied up to this point. Rest is algebra. All these steps, 1, 2, 3, 4, 4 steps, and maybe the fifth one is just algebra. Okay. Up to now, this is the point where you apply. Up to this point, you apply whatever you learn in this lesson here. So, make sense? Is there any questions? Okay, so let's do this. Let's do the other one. Okay, this is problem 22. This is problem 22. So you are given sine of xt equals t. So what you need to find is dt over dx. Okay, now you don't have y, instead of y you have t. Okay. So all I do is just take d over dx sine xt on this side, and then you do d over dx t. And you can, what can you do? You can apply chain rule, right? You take this as u, right? And then you do d over dx, sorry, d over du sine u times d over du d over dx u, right? Equals d over dx t. So d over du sine u is what? Cosine u, right? And d over dx u is d over dx xt equal d over dx t. Now what is cosine u? Cosine u is just cosine xt. And this is what? This is a, what is that? A product, right? So you can put product rule, t times d over dx x plus x times d over dx t equals d over dx t. Does that make sense? Is that good? So what is this? Cosine xt, right? This is t, is t, this is 1 plus x times d over dx t equal d over dx t. Now what do we need to find? D over dx t. Now it's just algebra after that. Solving this, that's it. Right? So I'm going to move this d over dx term into the other side. So we have x times cosine xt d over dx t minus d over dx t, right? Equals negative t times cosine xt. So what I did was I moved this term to the left hand side, this term to the left hand side, and this term t times cosine xt to the other side, right? And then I multiply these two, x times cosine xt times dt over dx, right? D over dxt, right? And kept it in this side. Does that make sense? That's just algebra, right? So you take d over dt, d over dx, sorry, should I have written d over dx t x cosine xt, x times cosine xt minus 1 equals negative t cosine xt. Then you can find dt over dx, sorry, dx, d over dx is equal to negative t cosine xt divided by x cosine xt minus 1. Does that make sense? Are we all good? Okay. So you can work out now most of these problems in this section. We have actually a different section within that section. That is actually derivatives of inverse trigonometric functions. Derivatives of inverse trigonometric functions. What are these inverse trigonometric functions? Now, if you are given a function like this, y is equal to sine inverse x, or you say arc sine, right? Arc sine x, same thing. So how do I find dy over dx? We can use what we learned the previous section just before. Right? To do this. How do I use that? If y equals sine inverse x, right? What is x equal to? Y equals sine inverse x equal to what? Very good. X equals sine y. Or I can write sine y equals x. Are you agree? Right, x equals sine y. Now what do I need to find? What do I need to find? I need to find, I'm going to find dy over dx. Can you do find dy over dx? We just learned. How do I find dy over dx? Can do that. This is an implicit derivative. Right? This is an implicit derivative. The things that we just talked about. We talked about these things, right? Did we? Yeah, we did. So what you do is you take d over dx sine y this side and d over dx x. Right? And how do I deal with this? D over dx sine y, because now y is a function of x, right? Y is a function of x. What is the method? What is that golden rule that we use? Chain rule. Use this. Chain rule. D over dy sine y times dy over dx equals, what about this side? The right hand side? 1, just 1, right? 1, good. So what is d over dy sine y? What is the d over dy sine y? Negative, negative or positive? Cosine y, just cosine y, right? Cosine y, dy over dx. Can we find dy over dx now? D over dx y. We get this. This is our goal, right? What is that? 1 over cosine y. 1 over cosine y. So if sine y is x, what is cosine y? If sine y is equal to x, what is cosine y? What is the definition of sine y? So if you have a right angle triangle, if this angle is y, right? And what is sine y? Sine y is equal to what? Opposite angle, opposite side divided by hypotenuse, right? So in this case, if it is x, what is hypotenuse for this triangle? What is hypotenuse for this triangle? No, the sine y is equal to x. So sine y is by definition, it's opposite side divided by hypotenuse. So what is the magnitude of hypotenuse according to this? It's opposite divided by hypotenuse. 1. Because this is x divided by 1. What is the opposite side? X. Then this side, what is the adjacent side? To y, angle y. How do you find? Can you find the length of adjacent side? Do we know something, some rule or theorem? Pythagorean theorem, right? So from that, what is that side? Magnitude. Equals 1. So what is that side square? So let's say this side is what? Side is a squared plus x squared equals 1 squared, right? So a squared is equal to 1 minus x squared. What is a equal to? Square root of 1 minus x squared. So this is equal to square root of 1 minus x squared. So what is cosine y then? What is cosine y? Cosine y by definition is adjacent side divided by hypotenuse. So what is the adjacent side? Magnitude is equal to 1 minus x squared, square root of 1 minus x squared divided by 1, right? So you have dy over dx is equal to 1 over 1 minus square root of x. So that means d over dx sine inverse x is equal to 1 over 1 minus x squared. Does that make sense? We learn anything new. Everything we knew before. We just build on it. So if you understand everything basics, this math is really easy. You don't have to memorize anything. Math is in fact fun. when you learn how to build on the things that you already know. Because you don't have to memorize it. Just have to keep some tabs on some points that you really, really need. That's it. Okay. All right. So you can do the same thing for this. Now, if I gave you y equals cosine inverse x, right? Y equals cosine inverse x, you can do the same thing. Okay. Then you need to find dy over dx. Okay. So you can find cosine y is equal to x. Then you do d over dx or derivate by x both sides. This is, take it as u, d over du no, you don't have to. What you can do is d over dy cosine y times dy over dx equal 1. So what is d over dy cosine y? Negative sine y, right? Negative sine y. Dy over dx equal 1. So what is dy over dx? Dy over dx is equal to negative 1 over sine y. Now, again, think about that triangle. Now, in this time, this is y. Which leg is magnitude x? Which side is magnitude x? Now, cosine y is x. What is hypotenuse? If cosine y is x, what is hypotenuse? What is the magnitude of hypotenuse? 1. Again, 1. Good. And what is the side of, what is the magnitude of opposite side? Because we need to find sine y, right? Sine y is what? Opposite divided by hypotenuse. Do we know what the opposite side is? X. Is opposite side x? What is given? Cosine y is equal to x. So what is side a? What is the length? Which side has the length x? Which side has the length of x then? Adjacent side, yes. This is x. So what about this one then? 1 minus x squared, square root. So this is what? 1 minus 1 over 1 minus. I'm sorry. It should be 1 minus x squared, square root over 1. Right? Then this is equal to 1 over negative 1 over 1 minus square root of 1 minus x squared. Then this is d over dx cosine inverse x is equal to negative 1 over square root of 1 minus x squared. that make sense? So by doing similar, in similar way, you can obtain the other equations for other functions as well. So d over dx tangent inverse x is equal to 1 over x squared plus 1 d over dx cotangent inverse x is equal to negative 1 over 1 x squared plus 1 and d over dx secant inverse x is equal to 1 over magnitude of 1 over magnitude of x by x squared minus 1 and d over dx cosecant inverse x equal to 1 over the negative 1 over magnitude of x times x square root of x minus x squared minus 1. Those things are also in your book. Which this battery is running out. Okay, so we can work out some problems. Starting this. Yeah. Let's look into some problems. So the first example, oh, she's dropped. So we have this one. Y equals sine inverse x squared. Y is equal sine inverse x squared. Let's try to do that. We gotta use all the things that we have used learned so far. right? Fine. Dy over dx. So you can use those equations, those equations that we learned for sine inverse x, right? So we can use dy over dx equals d over dx sine inverse x squared. Right? And here what we have is you can put this as u, right? So then you can write d over du sine inverse u times d over dx. U is x squared. That's chain rule. Okay, that's chain rule. So what we have done is let x squared equals u. Now what is d over du sine inverse u? Sine inverse u 1 over square root of u squared minus 1. Or 1 minus 1 of 1 minus u squared. I'm sorry. 1 minus u squared. Is that right? And then d over dx x squared, that is 2x, right? That is 2x. So you can write 2x divided by 1 minus u squared, u is x squared. So that's x to the power 4. And you can use several other function things. Let's see what functions. Is it? You can see cos inverse x squared, the same thing. Just writing to find some problems. 40, 38, 43. This is a good one. Take this y equals e to the power cosine inverse x. This is problem 38. Find dy over dx. find dy over dx, and that is actually d over dx e to the power cosine inverse x. What is the picture? What is the first thing that you have to say? Okay, so what is your function? How do you define your u function? Cosine? Yes, cosine inverse x, right? So you find very good. So you take, let u equals cosine inverse x. Now we can shape it. dy over dx is equal to d over dx e to the power, or you can directly write d over du e to the power u du over dx. Okay, so now I can use this one. We know how to do this. D over du e to the power u is e to the power u. And then d over dx u is d over dx cosine inverse x. E of x, u of, sorry, e of u is e of cosine inverse x. D over dx cosine inverse x is negative 1 over 1 minus x squared. So that's your answer. Right? You just need to figure out what you need to take as function u, and then you apply the chain rule. Does that make sense? And that's from the implicit derivatives. And one other thing that you need to know is that we can find the higher derivatives also by using the implicit derivative. For example, I do one example. X squared plus 2y squared, sorry, 4y squared, x squared plus 4y squared equals 7. This is actually a equation of a circle. And you have to find d squared y over dx squared, the second derivative. First thing is to find the first derivative, right? Same thing that we did earlier, d over dx, x squared plus 4y squared equals d over dx 7. Same thing that we did. And now we're going to go to the basics. What is the basic? Sum rule, right? Summation rule. So d over dx, x squared. That term we don't have any problem. Next one, 4 times, 4 is a constant, you can always take it out. D over dx, y squared. This is d over dx, 7 is equal to 1, 0. It's a constant, very good. So this is d over dx, x squared is 2x plus 4 times. Now the chain rule. D over dy, y squared times dy over dx equal 0. So this is 2x plus 4 times 2y, right? Dy over dx equals 0. So what is dy over dx? Dy over dx is equal to negative 2x divided by 8y, right? So this is negative x over 4y. That's dy over dx. So how do I find the second derivative? How do I find the second derivative? How do I go for second derivative? I have to derivate once it again. That's it. So you find d over dx, dy over dx equals d over dx negative x over 4y. Right? So over this side, it is what? D over d squared over dx squared y. That's the second derivative. And then what is in this side? What rule can we apply? Quotient rule. So if you do quotient rule, it is 4y squared, right? Now, which one is first to derivate? So the negative sign can be outside, right? That's negative sign, or you can take -1. And which term is to derivate first? Numerator or denominator? Which one you derivate first? Numerator. So you put 4y and then d over dx x, right? Plus, sorry, minus x times d over dx 4y, right? And then from this, it's negative 4y, because d over dx x is equal to 1 minus x. This is 4 times d over dx y divided by 4y squared, right? So you have 4 in here, 4 in here, and then 4 squared in here, so you can cancel 1, 4, right? And if you multiply by negative, this becomes negative y plus x times dy over dx divided by 4 times y squared. So that's d squared y over dx squared. So if you want, you can substitute for dy over dx from the previous answer. That's negative x over 4y, and then you can solve from there. Right? So basically what you can do is you can put negative y plus x. This is dy over dx is equal to negative x over 4y. And then put 4y squared there. And then you can solve it. Does that make sense? So that's how you do the higher derivatives. And so we will work out some problems based on the inverse derivatives. I put some examples, homework, and then we can work on them on Thursday. So tomorrow we are not going to meet here. I'm going to upload the videos as usual on Tuesdays, and we will meet back again on Thursday at 6 o'clock. And please let me know if you have any questions, okay? We can meet either virtual or in person, whatever you like. And I want you to pass the class. Sure.